Okay. So, you ready to try this now? Sorry that took so long. We're going to practice writing some value returning functions. Okay. So chapter 6 has a lot of stuff in it, but kind of one of the earlier concepts is the idea of a value returning function. So remember, a value returning function is a function that has a statement in there, usually at the end, that says return and then something. It's going to return something to the calling function. So let's just kind of review a few definitions and things, and I'll when we do it, when we actually write the code, I'll try to point these things out. I'm going to type these up. I could put them in the comments. Let me see. Today must be slow computer day. Let's see here. So remember some of these terms. We're going to have kind of these different parts of the function. We're going to have a function prototype. Remember what that is? You could think of the function prototype as like a declaration for your function. And so basically, what do you know about that? It's going to go at the top of your program usually. Say towards. Like before, it's probably going to go like after your header files and any constants that you have. After header files and any constants, any global constants, I'll say. Define. Okay. What else do we know about prototypes? The prototype is it's basically going to be very similar to the heading of the function, the first line of the function. So the same and consistent with the function heading with the semicolon added to the end. Okay. So that's the prototype. And hey, it just gives the compiler a heads up that hey, later on there's going to be a function and this is going to be the setup, right? Okay. So that's your function prototype. And then you're going to have the function call, right? The function call is the statement that's going to make it skip down, make the flow of execution skip down to the function and execute all the code in the function. All right. Let's say tells, say, makes it skip down to your function. Okay. So that's the function call. And then the function definition is the main code for the function. And the function definition has two parts, right? The function heading is the first line of the definition. And it's going to have things like contains the return type. That's the data type of the return value if it's a value returning function. If it's not a value returning function, it's going to have the word void there. Okay. It's going to have the name of the function. And it's going to have your parameter list. Remember, your parameter list is like input into the function, right? Okay. So anyway, so with that, let's do some actual programming. So go ahead and load up your compiler. So I suppose most people in here are probably using the Dev C++ compiler, right? So, and that's fine. Go ahead and use that. Here on these videos, I've been kind of using this CodeBlocks compiler, but Dev C++ works great. In fact, there's a lot of things that I like about it better. It's simpler. Wait, how did I do this? CodeBlocks. So CodeBlocks, you have to create a new project for everything. New, I think. New project, empty project. No, wait, it was console project. New project, new console application. X C++, and the name of it is going to be circle underscore functions. All right. So go ahead and type up this little template there to get things started. That's cool. One cool thing about CodeBlocks is that it'll start off with a little template there. So these are the things that we're always going to have, right? Your IO stream, header file, and using namespace and int main and so forth. I'm going to put some comments at the top. And basically what we're going to do here is we're going to redo that good old circle program that we wrote towards the beginning of the semester using value returning functions. So I'm going to put a block of comments up here at the top. I'm going to say program, circle program using value returning functions. You can put your name there if you want to. Compiler. This is the CodeBlocks, but you can put Dev C++ there. And description. So I'm going to say this program will utilize value returning functions to calculate things related to a circle and sphere. All right. And I'm going to save that. And so after you get that, that much should run, right? Doesn't do anything, but that much runs. So everybody good with that? All right, so let's think back to the circle program, and there were some other header files that we included, right? We included, there weren't that many things. We included CMath in order to use the power function, and we included IOmanip in order to use set width and set precision, if you remember correctly. Okay. Other things that we did, we set up a named constant for pi, right? You remember that? And so that should go here after you're using namespace line, but before main. I'm going to do that next. So I'm going to say declare constant for pi. Remember how to do that? We said const double pi equal 3.1415926 or whatever like that. Okay, so that's where I'm going to put that. And then after that, this is where I'm going to have my function prototypes. So I'm going to put a comment there, function prototypes. Okay, and we're going to come back and add those when we get to that point. All right, so let's go ahead and do some things in main. So you have, again, you have int main, open close parentheses, and then in curly brackets, all the code for main. The first thing that we did was we declared some variables, right, if you remember. So I'm going to do that here. And if you remember, we had the radius. So this is, we're going to basically redo the program that we did together in class. Not the cube one, but that you did on your first program, but just the circle one. So we had the radius, we had the diameter, we had the circumference, we had the area, we had sphere surface area like that. We had sphere volume. Anything else? I think that was it. Okay. So I've declared those inside of main. So we could say that those are local to main, and we'll talk more about what that means in a different lecture. But all those, main knows about all those things. If another function needs access to those or needs to know what those things are, we have to send them in as parameters. Okay. All right, so we've declared those. We could go ahead and compile that and make sure that that still compiles and runs. Okay, so I'm still good on that. So make sure that you didn't leave off any semicolons or anything like that. I like to compile every, once at more regular intervals. Sometimes I'll see students, they'll type a whole bunch of stuff up before they ever compile, and if you do that, you're more likely to have larger numbers of errors, right? So I think it's better to kind of get a framework going, add some stuff, make sure it compiles, and add some more stuff and add to it. All right, so what's the next thing we did? Well, we got the radius from the keyboard, right? So that's pretty easy. Let's just go ahead and do that here in main. Get radius from user. So we'll say cout enter the radius of a circle, and then cn radius, like that. Again, you could go ahead and test that if you want. So enter the radius of a circle. Oops. Type in a 5 or whatever. Okay, so it stores that. Everybody cool with that? So at this point, this is where back in when we were first doing this, we would have a whole list of calculations here inside of our main function, right? Instead of doing all the calculations here in main, since we're learning about functions, what we're going to do here is we're going to write several value returning functions. These are going to be really, really short functions, like one-line functions. In fact, you could question whether or not it's even worth it to just have these little one-liner functions here. But so they're going to seem a little silly, but if nothing else, it gives us some practice just kind of writing some value returning functions. Okay, that's what I'm going for here. So go down underneath main. So notice here's the end of main, right? The closed curly bracket, that's the end of main. So we're going to add another function. And so this function will calculate, we're going to set this up to calculate the diameter. Okay? And it's going to be a value returning function. So it's going to return whatever the result is. So it's going to return a double. So you put double as your return type, and then you have to name it. No, you don't want to name it diameter. We already have a variable named diameter up there, and so that could create some issues if we try to do that. I like to use a verb in my function names usually. So something like calc diameter or calculate diameter or something like that. So how about calc diameter, like that. So and again, I'm using that camel case notation that the book uses, and it's pretty standard these days. Double and then calc diameter. Capitalization, makes a difference. And then open parentheses. And then your parameter list. So what do we need to send in to calc diameter in order for this function to be able to calculate the diameter? What do we need to know? The radius, right? So we need to send that in as a parameter. So for each parameter, you have to list the data type, double, and then a name for it. So you can use the same name, or you can actually use a different name if you wanted to. I like to be consistent with it just so I don't confuse myself too much. So that's what I'm going to do. And then open and close curly brackets underneath there. So again, we're writing the function definition for calc diameter, right? And that first line is the heading. The heading tells us it's going to return a double. The name of the function is calc diameter, and I'm sending in one parameter. I'm sending in a double, and the name of it is radius. So all this function, we could write this as a one-line function if we wanted to. We could just say return radius times 2. That's all we really have to do. So in your return statement, you could just say return and then a variable, or you can actually say return and then a larger calculation like that, a larger arithmetic expression. So it's going to return whatever radius times 2 is. And that's your function definition for that one. Okay. Now that's not going to get done unless I have a call to it, a function call. So we'll add that here in just a second. But if I go ahead and add the function call, I'll probably get an error because in main it hasn't encountered calc diameter yet. That's why we have to use the prototype. We have to put the prototype. If you order your functions such that the definition of a function is above the function that the call is in, you don't technically have to have a prototype. But that's kind of a risky thing to do because it could get more complicated. You could have a function, you could call a function, and that function could call another function. You'd always have to make sure that the functions were in the right order and whatever. So that's just, I don't suggest that at all. So that's why using prototypes is the best way to go. All right, so up at the top, we need to add the prototype. Now, the easiest thing to do on your prototypes is just to copy and paste the heading. So we could just copy this first line of our function definition. And I'm going to copy it. And then up on our prototype, just paste it. I'll do Control V to paste. And then add a semicolon. So the prototype has a semicolon. The heading does not. And it's got to be consistent with what the heading says. So if the heading says that I'm sending in a string parameter, but the prototype says I'm sending in a double parameter, I'm going to get an error on that because it's not consistent. So it's got to be consistent. So it's returning a double. The name of it is calc diameter, and I'm sending in one double. Now, technically, you don't have to have the names of your parameters in your parameter list in the prototype, but you can if you want to. But technically, you could leave off radius in the parameter list in the prototype, but you still have to have the data types of all of the parameters. All right, so that's the prototype for calc diameter. Now let's write the call. So the function won't actually get executed unless you have a function call, and you put the function call at the point in which you want it to do the function. So I want to do this after I've gotten the radius. So go back down to main, and I'll just make a comment here. We're just gonna, they're all gonna end up being here. I'll put function calls. So calc diameter is a value returning function. If it's a value returning function, you have to do something with that return value. So you can either assign the return value to a variable, or you could use it in a larger calculation, or you could output it. Usually you're going to do one of those three things. What we're going to do is we're going to assign it to the diameter that we have here. So we've got diameter declared, so I'm going to say diameter is equal to, and then I'm going to call the function calc diameter. CodeBlocks is kind of cool because it's got a lot of auto completion things for you. Calc diameter, and then the name of the parameter that you're sending in. So I'm sending in the radius, like that. So on the call, you don't put any data types in your parameter list or anything, right? You only put what you're sending in. So diameter is equal to calc diameter and the radius. So it sends in the radius, it calls it, and so it skips down there to calc diameter, and technically it copies whatever this radius is down to that radius, and returns 2 times that radius. That return value gets assigned to that diameter. So yes, I know on this particular example that seems like overkill, but again, we're getting some practice with that. So does that make sense? So go ahead and compile and run that. And you're not going to see any results yet because we haven't output anything. But I think it's doing it. So does that make sense, what we're doing there? Yep. So again, functions, it's just a way of splitting stuff up into different kind of modules. So let's do the same thing. Let's get some more practice. We're going to do circumference the same way. So go down to the bottom, and notice all these functions are separate, right? You know, you don't have any functions that are nested inside of another function. For example, I don't have the code for calc diameter stuck inside of main or something like that. You can't do that in C++. They have to be separate. Double, calc circumference. That's what I'm going to name it. And I'm going to send in the radius just like I did with the calc diameter function. So all these are going to look very similar. The circumference was 2 pi r. Is that right? And also since I've done this. So we return 2 times pi times the radius, like that. And it knows what pi is because I declared pi as a global constant. I declared it up there before main. Okay? And it's usually considered okay to declare your constants globally. And if you declare them globally, then any function can access that thing. So you might think, well, why don't I just declare all my variables up there as well, like before main? And that's considered a bad thing because you would be giving the power to change those variables to any function. So there's something, I don't know if I mentioned it before. Have I mentioned the principle of least privilege in here? So there's something called the principle of least privilege that's a really good programming practice to have. And basically what the principle of least privilege says is that you should only give the power to do what it needs to do, right? So, and you could apply that to your life as well, right? So you're on, what is it? You're on a need to know basis and you don't need to know, that type of thing. So don't give the power to change something that it doesn't need access to, basically. So anyway, that's the good way to do it. All right, so we've got that. So let's go back and do the prototype and the call for calc circumference as well. Again, the best way to, or a good way to try to avoid making mistakes is to copy and paste. So I'm going to copy that and then paste it up here and add a semicolon. So there's your prototype for calc circumference. And then the call, I'm going to put this right after calc diameter. So I'm going to say circumference is equal to calc circumference, and I'm going to send in the radius. Like that. Circumference is equal to calc circumference. So we'll skip down there, send in the radius, and do the calculation and return the result, and the result gets assigned to circumference. So again, compile and run that. Again, you're not going to see any results yet. Okay. So let's go ahead and do the others. We can just kind of do all these pretty quickly. So we have area, right? So double calc area. I'm going to name it. This one is also needs the radius in order to calculate the area. The area is pi r squared, right? So I'm going to say return pi times pal radius comma 2, like that. And I'll go ahead and do the others as well. We have double, is it sphere surface area? So I'm going to say calc sphere surface area. So careful on your spelling on that one. And I try to be consistent with how I do things. So if that's kind of the name convention that I'm choosing, like calc and then whatever it is, I try to be consistent with that. Calc sphere surface area, and I'm sending in the radius as well. That one is 4 pi r squared, so return 4 times pi times pal radius comma 2. And one more. calc sphere volume. And again, I'm sending in the radius. And that one looks like this. Return 4.0 divided by 3.0 times, so 4/3 pi r cubed times pi times pal radius comma 3. 4/3 pi r cubed. And save that. So go ahead and add those functions. So after you get that, again, we're going to go up and add the prototypes and then the calls. Everybody good on that? So again, I'm going to do the prototypes. I feel like typing these or seeing if it'll auto-complete them. Double, what was it, calc area? Oh, no, I didn't auto-complete that. Double radius. And then calc sphere surface area. And double calc sphere volume. Again, you don't have to have the name radius in there, but you do have to have the double inside the parameter list. And don't forget your semicolons on each of those lines. Is that all of them? I think that's it. So we have a prototype for each function, and then we're going to have the calls for each of those. So here it doesn't matter what order we call them, but if any of the functions required one of the calculations to have taken place before, you have to make sure that you call them in the correct order. It won't end up making a difference here. Diameter and then circumference, area. So area is equal to calc area, and we're sending in the radius like that. And then sphere surface area is equal to calc sphere surface area, and we're sending in the radius. And sphere volume is equal to calc sphere volume. Again, we're sending in the radius. 1, 2, 3, 4, 5. Cool. How's that? We good? So I'll let y'all get caught up there. Does anybody have any errors they're stuck on? We're going to write one more function, and this function will just output all of our results. So yes, we could put the output lines here inside of main, but since we're doing functions, let's go ahead and write a function that does it. So I'm going to go down to the bottom, and I'm going to add another function. And we'll name this one output results. It doesn't need to return anything. It's just going to output the results. And so this is going to be a void function. So you put the word void as your return type. So void means it doesn't have a return statement in there. And let's name it output results, like that. Okay. Now we have several things that we want to output, right? So I've mentioned you can only return one thing with the value returning function, but you can send in as many parameters as you want to. Okay? So, and we have several things that we need to send in as parameters. And just to show that you don't have to use the same names as you use in main or the calling function, you can use different names. I'm going to use shorter names. So instead of naming it radius, I'll just put R. And then I'll put D for the diameter. And then C for circumference. And A for area. And SSA for sphere surface area. And SV for sphere volume. All right, so did everybody get that? I kind of went off this side a little bit. If you ever have a really long parameter list and you want to split it up over 2 lines, you can do that. Just do it, you want to do it after a comma, like that. All right, and then open and close curly brackets. And then I'm just going to have a series of output statements. So if we just want to output to the screen on this one, we can do that. We can say, well, we need to set up our stuff, right? So cout, what's it, show point, and then fixed. And I'll do set precision to 3, something like that. Set floating point output, and then we can have just a series of output statements. If you want to do set width and all that stuff, you can. It's up to you. Do you want to do that? Oh, it was, remember, it was left, and then set W, sphere surface areas. I don't remember what it was. How long was that longest line? Sphere surface area. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 18, 19, about 19. So I could shorten that a little bit, maybe to 20. All right, let me come back to that. Well, I'll go ahead and do it since we're doing that one. I'll go back and add the other lines, but sphere surface area was the longest text. That's why I did that. So left, and then set with 20, sphere surface area, and then we did right, and set W, something like, I don't know, what do we do? However big you want to make that, 15. And then SSA was the name of the sphere surface area here, right? And so I'm going to do that for each thing. In fact, we could copy and paste that line. and modify it. So the first one was the radius. So the name of the variable that we use here inside of this function is just r, right? Because that's what we decided to name it in the parameter list. So just to show you that you don't have to use the same name. So whatever your name that you choose here in the parameter list, that's the name that you need to use inside the function. And then we have the diameter. And I'm outputting D. And then I have the circumference. And I'm outputting C. And then I have the area. A. And then the sphere surface area. I had that one already. And then the sphere volume. And the name that I chose was SV, right? And this is a void function, so there's no return statement or anything like that. That's just the end of it. So I need to add the prototype and the call, right? Oh, wait, did I use, no. I'm sure I'll get back to that. Fine. Okay, everybody good on that? So now we need to add the prototype for that guy. So again, you could just simply copy and paste the heading. I did Control-C to copy, and then paste it up there with the other prototypes. And add a semicolon. And again, you could take out the names if you wanted to. You could take out the R and the D and the C, but you still have to have all the doubles in the list. You'd have to say double, comma, double, so forth. And then we're going to add the call. So I'm going to put the function call here after I've called the other ones. So if it's a void function, you don't have a return value to deal with. You just put the name of the function. So the name of the function is output results. And then in your parameter list, you have to list out the variables that you're sending. And in here inside of main, the names of them are radius, diameter, circumference, and so forth. They're not R, D, and C, right? So you have to put radius, diameter, And you need to send them in the same order. You got to be consistent with it. If you put the diameter first, then diameter is going to get copied down into radius in the function. So you want to be careful and not do that. I like the autocomplete thing. Like that. And again, you can break things up into 2 lines if you need to. Just do it after a comma. So now it's going to skip down to output results. It's going to copy all these things down to those parameters down there in the list, and it's going to output them to the screen. And it'll skip back. After the function is done, it'll skip back and then return 0 in main. So let's see if it works. So there you go. And I could add some little designs there if I wanted to in my output function. That might be more than I needed. There you go. Maybe another indel or something to separate it a little bit. So what do you think? Do I need to go back to any particular spot? And once again, that's probably kind of overkill for these little short functions. Here in a little bit, one of the next things that we'll talk about is the difference between value parameters and reference parameters. And we'll see how we can use reference parameters to maybe write one function that does all the calculations for us instead of having like 5 different functions or whatever. We can just have like one calculation function. We can send stuff in as by reference, and those changes will get remembered. But that's another concept. That's kind of the next concept. Questions? So you see all the different parts, right? So we have our function definitions. We've got our prototypes up at the top, and then we've got our calls that make it skip down to the functions. Okay. I'm going to go ahead and stop this video, and then I can help people